Testing 1 2 1 2 3 4. Let's do this. What's going on, YouTube? Thanks for joining for yet another episode on Clean Code. So, in this episode, I wanted to take a little bit more of a deep dive into the Clean Code book and who this book is for, why you want to learn it, and what's in the book. You know, you could go out there, you could buy it, you could read it. It's 400 pages. So why read 400 pages when I can just give you the highlights? So if you don't know me, it's your first time on the channel, I am the 618 developer, giving you guys a little bit more of an insight into more of a senior software engineer, software developer, coder, programmer, back-end guy, boiler room, basement programmer dude. This isn't tutorials. I'm not going to go through line by line of this book. We're not going to write up some code and do some screen sharing. This is going to be more of a, theory, philosophical review of the book. So right off the bat, chapter 1 is just an introduction to what Clean Code is, who the author is, who are the other authors, and just a little schools of thought from each of the other authors in this book. Obviously, the main one is Robert C. Martin, or as you may know, Uncle Bob. So that's what chapter 1 is about. The only big thing that comes out of chapter 1 is a big thing I like, and I'm glad they started off right away, is the Boy Scout rule. So for anybody that knows the Boy Scout rule, Boy Scouts of America, because some viewers might not be from America, the old be all that you can be in the army. That's totally not the Boy Scouts. But no, the Boy Scout rule is pretty simple. They teach you in the Scouts, when you go camping, leave the campsite always better than the way you found it. So do the same thing with code. You get thrown on a project, you get put on an assignment, and you're introduced to some new code that's written that you didn't write. Leave it better than you found it. Do a little updating to it, maybe write a couple of tests around it. Just do a little cleanup, leave the code better than you found it. The Boy Scout rule. Chapter 2 is then a big follow-up, meaningful names. This is a very good chapter about naming, and let's run over some of the highlights here. Use intention revealing names, make meaningful distinctions, use pronounceable names. Don't put, for the word display, put DSPLY. Is that display? Is that DOS play? Is that DSP? Linear Y index? Don't do that. If something is linear display as your instance variable, linear display. Hungarian notation, all that stuff. Avoid mental mapping. Talks about class names. Don't be cute. So again, don't try to be cute with your naming or anything like that. Name it what it is. If it's camera 1, camera 2, don't say camera dos minus 1 or something. Like it's camera 1, camera 2, or camera uno, camera dos, but don't add anything else in there that's extra. Don't pun. Use solution domain names, use problem domain names. So if you are doing kind of business domain driven design, business design, anything like that, you've got a vocabulary in the business. You can use some of those names. Big one here at the end I like to talk about: don't add gratuitous context. So what this is in the example in the book they talk about, you're writing an app called Gas Station Deluxe, so GSD. Don't take something like a mailing address and call the class, it's the GSD mailing address. Well, no, Sherlock, like it's in the GSD application. I would hope it's a mailing address for that. So don't add gratuitous context. Don't add a little, 3-letter acronym to a name, especially if it's in a package that is using the acronym. I've seen that before. It'll be the we have the ACL something class, right? And it's inside the package where it's com.thebusiness.services.acl, and then it's the ACL, blah, blah, blah. Like, don't. Stop. Chapter 4, comments. Now, this one is, it's a very, how can I say it? Not argumentative in a little bit, but it's very interesting, this chapter, because of the way at least I learned in undergrad about writing code. So in undergrad, when you were writing your code, comments were king. I remember a professor that wanted a blob at the top of your class that basically said everything this class does, and then on top of each method, he wanted comments there, like what's going into the function, what's coming out. If something's coming out, is it void? Is it returning an int? Is it returning another class structure? What's it doing? Stuff like that. Does it throw an exception? So, comment. And then when I got a real job and I started writing just you'd say a simple algorithm, think of a recipe method that's got 7 steps, and I start putting, step 1, do this, step 2, do that. The senior devs at that time just kind of looked at me and were like, can you remove these comments? We don't need them. And I'm like, oh, it's just nice and organized. And they're like, no, your code should do that. And I'm like, but that's how my teacher taught me. So yeah, no, your code should be, and I think they even say this, explain yourself in code. Your code should explain itself. Comments should not make up for bad code. Go back to chapter 2, naming. You write good names, you got good names for your variables, good names for your function, descriptive stuff. Your function's only doing one thing. You're following the clean code manifesto. You shouldn't have to write comments at all. I will actually go into code that any developers put up for a code review, and the moment I see comments, I don't even look at it. I'm just like, remove comments. Because if you have comments in there, there's a reason you're thinking you need to explain something to me that your code can't do. And let's strive for you to try to explain it to me in your code. Now, there are, of course, as always, exceptions to this rule. One of the big things is, if you're creating any type of API that's public facing, or public facing kind of in the sense of your enterprise is going to be used by a lot of teams, commenting code isn't bad. I remember back in the 2015-14 area, JavaDoc was a big thing. I remember one of my managers was like, let's make sure we have the JavaDoc written up around everything. Make sure you put those comments there. And I was like, okay, this is just used by us. It's not being used by anybody else. So he kind of talks about that a little bit. I think I remember in here, about JavaDocs, and actually, JavaDocs in non-public code. So it's okay. So if your code's going to be public, you're going to share it, you're going to put it out there on GitHub, I guess it's all right to put some comments in there. The other big thing in the book, when it says it is okay to put a comment in there, is basically if you've got to explain something that would make no sense in your code. Like if you got to hard code some mystery value because that's used by some mainframe server, and if you change it, it will freaking wipe out the company. Okay, let's put a little comment in there. So stuff like that. If there's literally some crazy reason, I remember in some code we were setting a value to 0.000001 or something. And I was like, most people just make that they'll name it a good constant up above or something, and then put that in place where we always set it like a default. And so we had to add a little comments in there about why we were setting it to 10-0. So stuff like that, it's okay. But if you're writing comments like, oh, create the object, set all the header information, set the body, handle errors, your code should be explanatory for that. So if you have to write a comment, the moment you start writing a comment, think, why am I writing this comment, and can I explain this in my code? Chapter 5, formatting. Not a big chapter that takes a lot of effort into. This is more about appearance, readability. Kicks off, it's basically two big things: vertical formatting, horizontal formatting. So vertical formatting, two big things that take away from here is one is vertical density, if I remember this right, vertical density. So let's say inside your method, you've got an if block, that's 3 lines of code, and then immediately after it, you're doing some other logic. Put a space in there. So it'll be your if statement, line, 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 your end bracket of your if. The next line, do not immediately have code on it. Give yourself an extra line in there, vertical density. Keep little areas of thought. You'll see that a lot in like setup methods where you instantiate an object and you're setting a bunch of stuff with it. It's usually good to break those in little pieces. It's just readability. The other big thing about vertical formatting is the newspaper method. This is something I really like. A little debatable, but I think it's great. And what the newspaper method says is that when you go into a class and you read the code, is you should always be going top down. You should not be going, top, down, back to the middle, maybe up to the top, down. You start at the top, and when you're going through a case of it, you always go down. You shouldn't be really jumping back up ever. And so what this kind of means, and where this debate comes, is the public versus like private methods. So a lot of people put all their public methods at the top, and then they'll put the private methods down below. So you could see a public method, and then you got a bunch of stuff, and then you jump down, to a private, which isn't bad. But what I've seen sometimes too is people write their public method, a couple of privates for it, and then another public method, and then a couple privates, and then they might reference one up at the top. No. What the newspaper method says is just kind of think of it as like you think like a tree structure type thing, like a sideways tree. Is function A is going to call function B. And then you have function C, and function C needs to also come function B. So what you're going to have there is you're actually going to have function A, function C, and then function B, because both of them are going to be using the function down below. So it reads top down like a newspaper, you're just going straight down. So I hope that was a good example. The other one is horizontal formatting. So left to right, don't have your line of code go like 120 characters to the right. I believe now, like IntelliJ, there's kind of like that little semi-transparent line that's basically like, hey, don't go past this. Kind of keep it nice and tight together. So you can set up like code analysis tools that'll tell you if you're too far indented over to the right. So that's what it's talking about in horizontal formatting. None other really was big. Indentions, it goes a little bit about how you should properly be indenting, and I can't remember if it's in this chapter. I always think of complexity. You should never go more than 3 indentions. So like an if statement inside an if. Once you kind of hit that third one, I think refactoring. Like I said, I don't remember if that's in this chapter, but it makes me think of that. The last one's kind of big, team rules. So, everyone's kind of have their own thoughts on it, and ultimately what it comes down to is the team's got to agree on a styling guideline, on a formatting guideline. And that is definitely best to do at the very beginning when you start a project. So if you're starting a greenfield project with your team, right away be like, hey, what do we want to set up as our formatting rules? We do one that was in ours is we do I think they call it the flat imports. So when you do your imports at the top, they're not dot stars. So if you're included the equals and the to and the this and that, if you're importing 5 methods, you're gonna have 5 lines of import. You're not gonna have a dot star. And the thing that I like about that, and I never really thought about it until coming over to a recent team, was it's very easy to understand in the code. When you see just the method EQ, you're like, well, what is this EQ? Like where did this import come from? And you go right away up to the top and you can see the full package that it come from. You're not wondering, well, shoot, I've got 4 packages up there at the top on the import and they all got dot star on them. What do I do? So I like the flat, like I said, I think they call it flat imports nowadays. It can be 50 lines of imports because, again, in modern IDEs now, IDEs, in modern IDEs right now, you can just click the little minus sign up there and it's all gone. You don't see it at all. You know, this isn't 1995. We're not printing out our code and reading through it. So it's okay. You know, if you've got 20 imports up there, that's all right. I like it. So kind of go with that. That's kind of on the team rules. Our team came up with that. And then another formatting thing like the team came up with is when you put in arguments in your function, if you have more than one, rather than A comma B, it's A comma space B. And you can set up, I think there's like an IntelliJ, there's like a settings you can do for formatting, so that when you do your old, like I do on a Mac, you know, Command Alt L, well, Command A to select everything, and then Command Alt L to format the whole class, it'll automatically do that spacing for me. Because I've literally gotten hit up by another dev in a pull request, everything's great, and they're like, you forgot about your spacing on your input variables. I'm like, okay, but again, team rules. Chapter 6, Objects and Data Structures. So not a whole lot in this chapter. Again, biggest thing that is talked about in here is, you know, abstracting your private variables. I know there's a big shift nowadays where people are like, man, why does Java do this whole private variables, public, private, you know, getters, setters, like all you're really doing, you're not really abstracting stuff. It's because people got lazy. They're not really understanding what the abstraction was. So a good example here in the book that I like to tell people a lot is a vehicle. So you want to get the fuel. You want to know how much fuel is in your vehicle. So in the concrete example of a vehicle here, you can get a double value that is fuel tank capacity in gallons. And then you can get the gallons of gasoline in the tank. So if the fuel tank capacity is 20 gallons and I get back gallons in the tank is 10, okay, 10 over 20, I'm at 50%. So what happens if you want to change any of that from gallons to liters or this or that? You got to change a lot of code. Whereas in like an abstract vehicle, there's a method that returns a double that's just get the percent of fuel remaining. So right away they've abstracted it. You know, you're not taking basically two like direct access or almost methods and doing a little computation. It's giving you an abstraction, like, hey, you want to know how much fuel is left? 50%. You know, whether it's 10 out of 20 gallons or 50 out of 100 gallons, unless that, you know, absolutely matters. If you're just displaying a fuel gauge, you don't care. All you care is, you know, are we full? Are we at 3/4, half, a quarter? Or are we, you know, 1/8 riding on fumes? So that's a little bit about data abstraction. And the other big thing it talks about in here is the law of Demeter. It says a module should not know about the innards of the objects it manipulates. So you can read up on the law of Demeter. It basically is like saying, you know, don't go inside of a method and do stuff with it. You don't care about that. You're just using its abstraction. And it kind of talks about, you know, you take a context and you're like context dot get options dot get scratch directory, like get absolute path. That's the next part where we talk about is a train wreck. You know, it's a dot something method dot something. You know, try to avoid those because it's going to cause some issues. One, you got, you know, if you're 4 dots, you got 3 ways you could have a null pointer in there. So now you got to add all these null checks. So that's usually a little bit of a code smell. It talks about hiding structure, data transfer objects, so DTOs. I always think of data transfer objects as POJOs. They're dumb. They don't have any logic in them, any functionality. Just straight, you know, simple fields. You know, they could be obviously like an address is just going to be like all string repetitions of like street, city, state, zip code, stuff like that. But yeah, it talks a little bit about transfer objects, and that's really all there is in chapter 6. Chapter 7, error handling. I mean, we can skip this. We don't write errors. We write great code, right? I write code, not bugs. I wish. So chapter 7, error handling. Not you know, kind of a boring chapter in my opinion, because I don't want errors to happen. So the biggest thing in chapter 7, I kind of mentioned it before, is, you know, use exceptions. Don't use error codes. Use descriptive exceptions. Error codes doesn't help anybody out. One of the other big things in here is talk about null. So don't return null. Don't pass null. Null. Then it gives a lot of good examples in here. I kind of like this principle, not passing null. I kind of really hate it when I see a method and someone's passing 2 arguments and then the third argument's null, and I'm like, why? That's crazy. If anything, hide it. Use a little polymorphism. Call the method with the 2 variables, which calls a private function that calls the third one with the null, and don't let the person know about it. Stuff like that. The other big thing in here that is kind of a key point that I like to tell people about is writing some wrapper classes around any third-party libraries that you use. So this is a good way to basically kind of decouple you a little bit from that third-party library in case anything changes, you want to make any switch ups in the future. It's also a big help when you upgrade versions. So if you this actually kind of goes more about writing tests around it. But if you upgrade from version 2.5 to all of a sudden you went to 3.1, if you wrote tests around all the third-party methods that you're using, you'll right away know, hey, did anything break from going from major version 2 to major version 3? I think the key point he says in here, in fact, wrapping third-party APIs is the best practice. When you wrap a third-party API, you minimize your dependencies upon it. You can choose to move to a different library in the future without much penalty. So use a wrapper, folks. You heard it here. So yeah, that's pretty much chapter 7, error handling. So I actually kind of gave the spoiler alert for chapter 8, boundaries, and talking in chapter 7. So chapter 8, this is the chapter where he talks about writing unit tests around a third-party API, the log4j. So writing some unit tests around it to where if the version updates, you'll know right away, hey, is this going to break our stuff? Another one big thing that talks about in boundaries, and this is actually really key if you've ever read Clean Architecture. If Clean Architecture is next on your to-do list for reading, is using code that does not yet exist. So write your code to an interface. They use an example here like a transmitter with a public method called transmit. It takes frequency and a stream in it. So you can write all your code to that interface, and that way whenever that code actually comes in, you're good to go. So there's probably a little bit more deeper that I'm skipping over. But yeah, he talks about clean boundaries as the last note. So chapter 8 is very short. It's literally 1, 2, 3, 4, 5, 6. Okay, maybe it's not very short. But it's only like big things, using third-party code and, keeping the boundaries, keeping that separation, decoupling you. So that's all in chapter 8. Chapter 9, test, unit test. Some of you people out there don't know what these are, and I'm shook. No, actually, a lot of people out there don't know what unit tests are. It's crazy. I had a guy on my team that had about a year experience, and I was pushing writing unit tests, and he was like, well, why? I wrote the code and I run it locally and it runs. Why didn't you write a unit test? I'm like, okay, because we really need to go into this, why we write tests to make sure when we write more code we don't break rules. Basically, I always think of it as rules, tester rules, tester use cases. When I hit the flip switch button, I expect the light to go off. So I want to write a test every time that we add code that when I flip the switch, the light still just goes off, nothing else. So that was a fun conversation. But yeah, unit tests. So he starts off kind of telling a little about test-driven development, which, by the way, is a game changer in your arsenal, in your toolbook of writing code. I've gotten slowly into test-driven development in the past couple of years, and I say slowly because it is a mindset change. Writing your tests first before you write production code. A lot of guys just want to write the production code and run it locally and see, all right, does this work? Okay, I'll go back and write a test. It's terrible, Write your test first. And here's a good reason, just kind of sidebar on why you should write your test first. Writing your test first pretty much should guarantee that you have pretty much 100% code coverage usually, or pretty damn close. And the other thing is you're not writing garbage code. You're not writing any extra junk. You're not writing fluffer code. You follow test-driven development, which you write your tests. It's not compilable. You're able to write your production code where it compiles, and you run your test fails. You're able to write just a little bit of code to make it pass, and then you're good. And if you satisfied the concept of your test, you don't write any more code. You don't do any more. Stop. You don't write any more code. So that's a good thing. So test-driven development, and, look it up. I'll probably do a video on test-driven development a little bit later, a little more in depth of what I've learned and kind of the steps. If you've never really been big on writing unit tests, or you just kind of know a little bit about unit tests, immediately jumping into test-driven development might be a little hard. But I'll probably talk about that in another video. So it talks about that with unit tests. The biggest key thing about unit tests that you write, readability. Make sure people can read them, make sure people understand them. Use good naming conventions. I can't remember the way it goes, but like one of the conventions is basically I write it's like 3 parts with underscores between them. Like first part is like the method that's basically being called, the AAA, what is it? Arrange, act, assert. So what method is the act? So what is going on? So the act, like, flip switch, what is being given? Like what's the setup, toggle switch. And then what's the outcome? The last part, what's the outcome? Light goes off, I don't flip switch, something like that, or powers out, flip switch, nothing happens, exception, something like that. So that's around tests. And then the last one, he kind of throws a little acronym at you. Test should be first, fast, independable, repeatable, self-validating, and timely. So it goes a little bit of that. Your test should be fast. Your test shouldn't take 7 minutes an individual test to run. Independent, it's basically testing kind of one thing. I'm totally paraphrasing some of this from what I remember. Repeatable, you should be able to basically run that test one time, and I could run it 50 more times, and I should get the exact same result 50 times in a row without touching the code. If I run it 50 times and it's a coin flip, we did something wrong with the test, or we did something wrong with the code. So that's chapter 9, unit test. Chapter 10, pretty much really the last kind of, I would say, meat and potatoes chapter of this book. It's around classes. So we talked about functions, so think of it now, we're going to layer out, we're going about classes. It talks about the single responsibility principle in here, cohesion, organizing for change, so isolating yourself from change. It's not really a whole lot, encapsulation a little bit, class organization. So just again, kind of some of the stuff you've already been a little exposed to, mostly when it came to naming and it came to your functions and reading about single responsibility. He just takes that up to the level of classes. So that's really all he throws at you from chapter 10. After that, the book basically is kind of goes in a little different direction. Chapter 11 is systems. He's talking about Java proxies, Aspect-J, test drive, the architecture. So it's talking about systems. 12 emergence, so simple design rules like running all the tests, then refactoring, no duplication, expressive, minimal classes and methods. Again, kind of just more, it's kind of a lot more examples. 13 was about concurrency, so some misconceptions. Know your libraries, know your execution methods. So basically know what you're doing, what you're using. Chapter 14, successive refinement. Man, I don't even remember what chapter 14, excessive refinement. Use descriptive names. It's a case study and successor. Oh yeah, this is like a case study stuff. So yeah, some of these are kind of more, like I said, case studies. 15 was talking about JUnit internal, so he kind of just does a little deep dive in JUnit. He gives an example in chapter 16 on refactoring the serial date class. So, make it work first and then make it right. So yeah, and chapter 17 is basically all the smells and heuristics of coding. So, comments, environment, functions, just some Java stuff, names, tests. And that pretty much, uncovers the book. There's an appendix after there, again, with a couple examples. So that pretty much wraps up the book, Clean Code. So like I said, if you haven't picked this up yet, go pick it up out there. Pick it up from Amazon. I'm going to have a link down below for it on Amazon where you can pick this book up. It's really good. What I like about this book mostly is while it is a cover to cover read, it's one of those kind of Bible books, I call it. You can always go back to it. You're in a code review and somebody's, rather than using descriptive names for their instance variables, they're like using A1, B3, C7, J, which you can use I and J in a for loop because that's like just a standard, but car X, no, car, truck. That probably was confusing without actually seeing it in code. But yeah, you get to go back to it. So I love this book. I've had this for probably about 6 years now. I've read it honestly probably like 7 or 8 times cover to cover, and then I find myself in code reviews kind of going back to it and stuff. This is not ironclad, like you must do what Uncle Bob says. You'll actually probably find some videos out here on YouTube where people are like, dude, clean code is dead. It's stupid. No one does that stuff. It was written in the early 2090s or something like that. I don't even remember. I'm making up as I go. Uncle Bob's a joke, all this stuff. So yeah, whatever. But you'll find a lot of places. I mean, here in St. Louis, you mentioned clean code and stuff like that. People's ears kind of perk up and everything. They're like, oh, hey, clean code. I don't know how it is out there, on the east and west coast, especially out in the valley in the west. Man, there's probably super clean, antibacterial code book written out there that, we'll get here in St. Louis in, 7-10 years. So yeah, that's really about it. Let me know, in the comments below what you kind of thought of this. I might have rambled a little bit, maybe not have given you a really good description. This could have been a waste. If you maybe want to see more in-depth video on some of these chapters, I could see myself grabbing a chapter or two out of here and showing up, maybe like, I can kind of take some production code I have from clients, mix it up a little bit and give some examples, potentially. But yeah, this is just a good book I have in my arsenal. I think a lot of developers should read this. It doesn't matter if you're a senior developer, if you're a developer on day 2, pick up this book, read it, and most importantly, have an opinion about it. So thanks for watching the book. Thanks for watching the book. Told you, we're doing one takes, man. I'm not doing all this fancy editing. Thanks for watching this video. If you like this stuff, hit subscribe, turn on the notifications. You can follow me on Instagram, 618_developer. I kind of post a little bit on there, kind of give me a little preview of what I'm thinking. Like I said, put in the comments below your thoughts if you want to see some other stuff. And as always, I'll see you guys in the next video.